Welcome back to The Explainer. Today we're putting on our cartographer hats, anatomical map makers, if you will. We're going to decode exactly how medical pros navigate the absolutely mind-boggling 3D space of the human body. Because, just like a geographer relies on longitude and latitude, anatomists have a super specific toolkit to chart our biological terrain. Let's get into it. Okay, let's dive right into the central mystery of medical imaging here. Have you ever actually stopped to wonder how doctors can stare at a completely flat 2D image on a screen and know with pinpoint accuracy where a tiny microscopic structure is buried deep inside your 3D body, all without ever making a single surgical cut? Well, today we're figuring out exactly how we peek inside a solid biological structure and actually make sense of it. So here's our itinerary for this journey. We'll start with mapping the human landscape, move on to imaginary slices or body planes, then tackle the sagittal plane explained. After that, it's midline versus unequal halves, and finally we'll wrap with the power of left and right. Section 1. Mapping the human landscape. Listen, every great map needs a reliable compass, right? The human body is no different. We have to establish a North Star for our map. Picture someone standing completely upright, feet shoulder-width apart and parallel, toes pointing straight forward. Their arms are out to the sides, and, this is key, palms are facing directly forward. This is the anatomical position. It's the universal standard. Why? Because it makes sure all of our directional terms make sense, no matter how a patient is actually positioned in real life. Prone, supine, doesn't matter. The map never changes. So the palm side of your wrist is literally always the anterior or front, even if your hands are resting palm down in your lap. Kind of wild when you think about it. And honestly, that brilliantly highlights why standardizing our view is just absolutely crucial. The human body is this vast, complicated 3D landscape, and anatomists are the cartographers charting its coordinates. Without this baseline standard position, trying to locate internal structures would be total spatial chaos. Imagine a surgeon trying to explain where an organ is if left and right or front and back completely changed every time you rolled over. Yeah, precision is literally everything here. Section 2. Imaginary slices, also known as body planes. All right, so now that we're perfectly oriented, we need a way to actually slice this 3D landscape up into readable maps. Our sources define it beautifully. A section is simply a two-dimensional surface of a three-dimensional structure that's been cut. The big takeaway here? Modern medical scans, like your MRIs or CT scans, they're essentially just virtual sections. They let clinicians look at perfectly flat surfaces of a solid 3D form. We're basically taking a dense, three-dimensional reality and compressing it down into a 2D image that we can easily study on a screen. I actually really love thinking about it like a magician's illusion. It's exactly like sawing a person in half, except, doctors do it virtually to save lives. They're using these imaginary geometric planes passing right through the body to pull off this totally non-invasive trick. It genuinely gives them a superpower, peeking inside our biological machinery without ever touching a scalpel. So we've got three primary intersecting planes that give us our complete 3D coordinate system. First up is the frontal or coronal plane. That splits the body into anterior, the front, and posterior, the back. Next is the transverse or axial plane, which divides things horizontally into superior, the upper part, and inferior, the lower part. And finally, the star of today's explainer, the sagittal or lateral plane. This one divides the body cleanly into right and left sides. Put them all together, and these three planes basically form the X, Y, and Z axes of human biology. Moving on to Section 3, the sagittal plane explained. Let's just push the coronal and transverse planes aside for a second and really zero in on this left-right dynamic. The sagittal plane is a vertical cut that runs straight from the front to the back, separating the body into right and left portions. This specific imaginary slice is exactly what lets us understand the lateral, side-to-side relationships of our internal organs within the body cavities. When a doctor needs to see the profile of your brain, or maybe the side view of a torn knee joint, they're pulling up a sagittal view. To really cement how this vertical division works in the physical world, try a quick visualization with me. Step 1. Sit or stand in that anatomical position we talked about earlier. Remember, palms forward. Step 2. Visualize a massive pane of glass just dropping vertically right through you, slicing from the tip of your nose straight through the back of your head. And step 3, look at those newly separated left and right sections. Boom, you've just mentally constructed a sagittal plane. Section 4. Midline versus unequal halves. Now, here's where things get super specific. Not all left and right divisions are perfectly equal, right? Which brings us to a really vital anatomical distinction. You've got to grasp this binary contrast. On one side, we have the midsagittal, or median plane. This runs exactly down the midline of your body, giving us perfectly equal right and left halves, dead center. But on the other side, we have the parasagittal plane. This is an offset vertical cut. It still gives you right and left sides, but they are totally unequal. Imagine that pane of glass dropping through your right shoulder instead of your nose. That right there is a parasagittal plane. And hey, a quick practical tip for you. The parasagittal plane is also sometimes called a longitudinal section in clinical settings. That is a super handy piece of vocab to keep in your back pocket if you're ever scanning medical reports that focus on just one side of a limb or maybe a specific organ. Like if a radiologist is looking longitudinally at an artery in your left arm, well, they're using a parasagittal view. Section 5. The power of left and right. So why do anatomists obsess over this specific vertical split? Well, because these concepts are baked directly into everyday medical applications. First off, it completely standardizes how we interpret MRI and CT scans all over the globe. Second, it lets us navigate using directional terms like medial, meaning toward the midline, versus lateral, which means toward the side. So you instantly know your heart is medial to your lungs, for instance. Third, and maybe most importantly, it prevents catastrophic surgical confusion. It guarantees a surgeon knows exactly which side of an uneven parasagittal split they're operating on. At the end of the day, it translates crazy complex 3D biology into a readable, actionable 2D map. These imaginary planes are, quite literally, life-saving tools. And that brings us to the absolute frontier of medicine. Think about it. If 2D anatomical planes conquered 3D anatomy and allowed us to safely navigate the human body, how is future tech going to map our bodies in 4D? Imagine adding time and movement to the mix, watching a living, beating heart function in real time across shifting sagittal planes. Pretty mind-blowing, right? I'll leave you to chew on that provocative thought as we wrap up our cartographer's journey for today. Thanks so much for exploring the map of the human body with me on this explainer. Keep learning and always stay curious.